Hello, welcome Math AH to lesson 5.3e. We're talking about percent increase and decrease, markups, and discount. So a markup is when we increase a price. So if you are a company and you buy a shirt for $10, of course you wouldn't turn around and sell the shirt for $10 because you wouldn't make any profit off that. So we have to mark something up so that we can make profit. So this is an increase. It's not letting me type up there. There we go. Increase. Okay, and of course a discount is a decrease. All right, find the missing value. Define a variable, use a proportion to solve, show all your algebraic steps. So we want the original price. We want to increase it by 40% to get the final price. So we're trying to figure out what the final price is. So we need to take the original and increase it. So the original is 100% of what we had. And we are going to increase that 100% what we had, increase percentage, over 100%, because that's the best percent you can have. Okay, and that is going to be equal to our final price over our original price. So that is our basic setup to figure out what the final price would be. So now we're going to plug in to our fraction. So the 100 is always going to be there. We have 100 plus 40. So this is 140%. Our final price is what we're looking for. That's our X. Our original price is $16.20. Okay, so I have to decide if I want to scale up or if I want to do cross products. Whatever you like would be fine. Easy to go scaling down from $16.20. That's just 0.1620 because the 100 would move it 2 spots over. So I see what I can multiply by easily. But if you don't see that, you can always stick to cross multiplying, and that would be totally fine. Okay, so I get my calculator and go 140 times 0.1620, and I get that X is equal to $22.68. So I know that the final price will be that. I answer in a sentence. The final price is $22.68. Okay? Decrease. Well, if we're decreasing, we're taking away. So instead of adding, we're going to subtract. Okay, so it's pretty similar to the other one. We're going to go 100 minus our decrease percentage over 100, because that's our best percent. And that is going to be equal to our final price over our original price. Get some fraction bars in here. Whoops. Okay. So I'm plugging in. I'm going 100 minus 74%. So if it's 74% off, I'm going to be paying 26%. So 26 out of 100 is equal to, we're looking for a final price, and my original price is $75. Okay. So again, you can scale down or you can cross multiply. Going from 100 is pretty easy to scale down. Here I have to multiply by 0.75. So then when I do that, I get $19.50. So the final price is $19.50. Okay, so our basic setup, if we want to increase, we're adding our percentage to 100. If we want to decrease, we're subtracting our percentage to 100. And it's always final price over original. And it's always what we have up here over 100 because 100 is our biggest percent. Okay, so now we're going to apply this to actual word problems. A $45 ski jacket is now on sale for $36. What was the percent decrease? Now this is different. We are just looking for the percent decrease. So you have to think of what you are looking for. If you're looking for the percent decrease, well, that lines up with the discount. Okay, again, we're still going to go over original, and we're still going to go over 100. So down here, our percentage is always out of 100. And this is our original price. Okay, so we can plug it in. A $45 ski jacket is now on sale for $36. So if I want the percent decrease, then I need to know what the discount was. So I don't put 36. That's the final price. I want the discount. So from 45 to 36, we saved $9. So my discount was $9. My original was 45. I'm looking for the percent off out of 100. Okay. So I don't particularly know what it scales up by, but if I reduce, it's quite easy. 9 over 45, I think, hey, that's 1/5. And I am looking for what goes out of 100. Well, scaling up, I know I have to multiply by 20. So x equals 20. Now, I didn't have to go grab my calculator, but if you wanted to cross multiply instead, you could have no problem. So here, it was a 20% discount. Remember, this is a video, so if you need to stop, rewind, you can. All right, so what I would do is pause the video, try 4, 5, and 6, and then play it and see if you are understanding. Number 4. At the beginning of the school year, there were 25 students in the karate class. By May, the class increased 20%. How many students were in the class in May? So May is a final. We want what the final count is. So we're looking for the final. We know we have to go over the original. And we know on the other side of our fraction, we would have had our 100 plus our percent increase. I have to move that over 100. That's our basic setup. I don't always write my basic setup down, but it's new to you, so it's okay. Okay, so our original, there was 25. I'm looking for how many people our final is. That's my x. I know that it was a 20% increase. Up here is 120. Over here is 100. Okay, scaling down from 100. I know I'm multiplying by 0.25. So I have to multiply 120 by 0.25. And when I do, I get 30. So in May, there were 30 people in the class. Okay, number 5. The population of a city is now 12,000 people. The population is expected to increase by 15% in 10 years. What is the projected population? So once again, we are looking for our final. So we can take this right here and copy it because we're doing the same kind of setup. Same type of setup. Okay, so there's going to be an increase of 15%. So in the end, I'm going to have 115% of what I started with. I'm looking for my final. That's my projected. I had my original 12,000. Okay, so I can look at this proportion and I can scale up. That'd be multiplied by 120 because 100 is going to add 2 zeros to it. So I have to multiply 115 by 120 and I get 13,800. So the projected population is 13,800 people. Number 6, after a 16% increase, the price of a pair of shoes of running shoes was $40.60. What was the old price of the tennis shoes? All right, so I've got a final price. So again, same setup. So I'm going to control copy that over here. Add my details. Okay, after a 16% increase, so 100 plus 16 is 116. The pair of shoes was $40.60. That is the final price. What was the old price of the shoes? I'm looking for the original. Okay, so in the top of my head, I do not know what 116 times what to get to $40.60. So I'm going to go ahead and cross multiply. Remember, the diagonals, the product of the diagonals, the product of the mean diagonal is equal to the product of the extreme diagonal. So we get 116 times x is equal to 100 times $40.60, which of course just moves the decimal over 4,060. Then I can divide both sides by 116. And I get that the old price was $35. So how'd you do? Did you get them right? All right, try the next two. So pause the video, try the next two, and see if you can get them right. Number 7, Martha bought a bike that has been discounted 60%. If she paid $96, what was the original price? Okay, so I have to remember, we're looking for the original and we've got the final. So this was 100% minus the discount percentage or decrease over 100 again is equal to the final price over the original. So our basic setup. Okay, so if it was 60% off, it was discounted 60% off, then she paid 40%. She paid $96. We're looking for what the final price is. Again, I look at that 40 times something to get to 96. I don't know off the top of my head, but I see that I can reduce that left fraction, that left ratio to 2/5. That's going to make my life way easier. So I like to reduce. Now I can see what I need to scale up by. I know that 2 times 48 is 96. So I'm going 5 times 48. And when I do that, I get $240. So what did she buy? The bike. The bike was originally $240. If a store buys a shirt at wholesale price of $13.50 and then sells the shirt for $24.95, what is the percent markup? So this time we have to work a little bit because we just want the percent markup. We don't want 100 plus the markup. We just want the percent of increase. Where did my typing go? The increase percent over 100. So if we only want the increase percent over 100, then we have to only get the markup, just the increased money. Yeah. Markup over the original. We're not looking for the final price of the original. All right, so I have to do a little thinking because I want to get just the increase percentage. If a store buys a wholesale price of $13.50 and sells it for $24.95, so I have to know, oh, well, they marked it up $11.45. So that's the markup. The original was $13.50. So that's a huge markup. It's almost the whole price. It's going to be a big percentage. Then this is the X, and this is 100. Okay. I don't know off the top of my head what scales up, so I'm going to go ahead and cross multiply $11.45 times 100 is equal to $13.50 times X. Move the decimal 2 spots over. 1,145 is equal to $13.50 X. So then I'm going to divide. Okay, we don't come out with a nice decimal. That's okay. We get X is about, when I look at my calculator, when I calculate this, I got to throw it in my calculator here. $1,145 divided by $13.50. I get this crazy decimal. 84, and I guess the calculator is rounding it even. 814, 814, 814 is repeating. Okay, but it says round to the nearest tenth. So the tenth is in this position right here. The 1 just leaves it not rounding up, just leaving it down. So we get about 84.8%. So the shirt was marked up about, because we rounded, 84.8%. Okay, try number 9, A and B. So pause the video, try 9A and B, and then see if you got it right. Find the new value when given a number is increased or decreased by the given percent. A skateboard that sells for $165 has been sitting around at Hanson's. The board manager would like to offer 20% discount of that price to see if he can go on sale quicker. How much would he sell it for at the discount? So that means we're looking for a final price. So, and we are having a discount. So we're going to go 100 minus the decrease percentage over 100 equals our final price over our original. All right, he's going to take it 20% off. So 100 minus 20 is 80. The original price was $165. We're looking for the final price. Okay, easy to scale up from 100. I'm multiplying by 1.65. 80 times 1.65. We get 132. So the final price would be $132. He would sell it for $132. A diamond dealer bought a small diamond for $84. To make money and stay competitive with other dealers, she must turn around and sell it to the public for a 145% increase. How much would she sell this diamond at this increase? Okay, so instead of doing a decrease, we're doing an increase. 100 plus the increase percentage over 100 is equal to the final price over the original. So she's going 100 plus 145. She's selling it for 245% of what she got it for. Her original was 84. We're looking for how much she's going to rip you off with. All right. So 84 times what? All right, we're scaling down. So 100 times 0.84 gets you 84. So I now have to multiply by 0.84. 245 times 0.84 gets me $205.80. So she bought it for $84, but is going to sell it to you for $205.80. She will sell the diamond for $205.80. Okay, pause the video and try number 10, A and B, and see if you get it right. Find the original value when given number of results increasing or decreasing the original value by the given percent. Study suggests that smoking disease decreases life expectancy by 25%. If the average non-smoking female lives to the age of 80, what would be the life expectancy if she was smoking according to the statement? Okay, so we're looking at a decreased percentage and we want the final life. So 100 minus my decreased percentage over the original over 100 is going to be equal to my final death year over what it would be if I wasn't smoking. All right, so we're taking 25% off of your life. So if you want to smoke, you're only going to get 75% of your life. We're looking for how long you will live. If you didn't smoke, you'd be living to 80. I want to know what happens if you do smoke. This scales down by 0.80. 75 times 0.80 is 60. So you get to die 20 years earlier because you were smoking your cigarettes. The female should die at 60 years old. One fall day in San Diego, the temperature was 51 degrees Fahrenheit. If the temperature is a 40% decrease in the temperature the same day in Honolulu, what is the temperature in Honolulu? All right, so 100 minus the decreased percent over 100 equals the final over the original. So what happens on this problem is people put the wrong city in the wrong place. So I have to think a little bit. Okay, so we see the 40%. So that one's easy. Everyone gets that part right. 100 minus 40 is 60%. But we have to decide, what was the original? The San Diego temperature, it was a decrease. So it was the final. It was after the decrease. So 51's on top. Honolulu is warmer. So we have to put it on the bottom. Okay. I don't know 60 times something to get to 51 on the top of my head, so I'm going to cross multiply. 51 times 100 is equal to 60 times x. 5,100 equals 60x. And divide by 60, I get 85. So in Honolulu, it was 85 degrees. In Honolulu, it was 85 degrees. Fahrenheit. All right, last page. Hanson bought a skateboard deck from the manufacturer for $59 and then marked it up for 50% to sell to customers. For the holiday sale, they put the product on sale for 25% off. What would the cost be to the customer round to the nearest cent during the holiday sale? Okay, so we've got two things going on. First, we have to deal with the markup. Okay, they thought, hey, I can sell it for this. But they realized, it's not happening. So then they took that same item and they put it on sale. So we're going to have to do this in two different phases. So for the markup, of course, I'm doing my 100 plus my increase percentage over 100 equals my final over original. And then for my sale, I've got to do a discount from what I had. Okay, so let's do step one first. We're taking we're going to mark it at 50%. So 150 over 100. Hanson bought it for $59. He would love to sell it for, dun, dun, dun. We need to multiply by 0.59. Okay, so 150 times 0.59. For $88.50. But it's just sitting on the shelf. So then he's going to take this price, not the $59. He's going to take this price and take a sale off of that price. Okay. So now we've got to go over here and do a discount. 100 minus the decrease percentage over 100 equals our final sale price. Final over original. Okay, so this one we're taking this over here. So we have 100 minus 25% off. So that's 75 out of 100 from $88.50. So that's why when you go to a store and they're like, sale, this much off this, well, you don't know how much they marked it up in the first place. So you don't really know what kind of sale that is. Okay, multiply by 0.885. 0.885. So 75 times 0.885. We get 66.375. Well, it's money, so we got to round up. So he's going to want to sell this for about $66.38. Still more than he paid for it. Whoa, lots of emojis. I don't want them. Okay. At the holiday sale, the skateboard price will be about $66.38. Okay, so again, this is just putting our formulas that we've written 5 million times now. So control copy. This is what should go on your note card. Okay, if we want to increase, we have to do 100 plus the increase equals final over original. And if it's a discount, then we have to do 100 minus the percent decrease equals the final over the original. All right, that is it for this one. So finish where you're at, hit save and turn it in. I'm gonna go hit my save. Okay, we're saving. And goodbye.